So for acids and bases, the first thing you have to learn is how to identify whether something is an acid or a base. So in the first question here, we're going to talk about how to identify the Bronsted-Lowry acid and their conjugate, which may be the conjugate acid or base. So here's the first problem where we have ammonia plus HCO3 minus, which is the hydrogen carbonate ion, and giving the ammonium ion and carbonate ion. So what you're looking for is, of course, acid and base, and here is the negative and here is ammonia. Okay, and ammonia is always going to be your base for most part, which means that this must be the acid. Okay, so then you look at the base, and the base is usually going to give you, well, always going to give you the conjugate acid, and the acid is always going to give you the conjugate base. The other way to tell whether you have a conjugate acid or a base is that you look at the protons, okay, over here. So if you have more protons here versus, like, say NH3, then this is the conjugate acid. All right, so in carbonate versus bicarbonate, the bicarbonate has, or the hydrogen carbonate has, an extra hydrogen, so therefore the hydrogen carbonate is the acid, whereas the carbonate ion is going to be the conjugate base because it does not have that extra hydrogen. So then let's look at the next problem. Here we have phosphoric acid plus water to give the dihydrogen phosphate ion and then hydronium ion. So again, you can look on the left side or you can look at the right side to start your answer. And if you want, let's look at the right side this time. Okay, and so here is my negatively charged species, and usually for me the biggest clue is whatever is negative is going to be basic and whatever is positive is going to be acidic. Okay, and also this is H3O plus. H3O plus right away tells me that I have an acid, okay, because that's what makes up acids. And then this must be then the conjugate base, and remember on the right hand side of the equation you will always have conjugate acids and conjugate bases. So then all you have to think about is where they are coming from, and so the conjugate base is coming from this acid. Remember, bases always comes from acid, and then the conjugate acid here is coming from a base. And usually water is the harder one because water is amphoteric, which means it can be both acidic and base. So you have to decide whether it's going to be acid or base depending on what it's reacting with. So phosphoric acid very normally an acid anyway, so which means that the water must be the base. So phosphoric acid gives us the conjugate base. Okay, our next problem is write the conjugate acid base, okay, of the following things that are given to you. Now for you to decide whether you're writing a conjugate acid or base, you have to see what you're starting with. So here is starting with sulfuric acid, H2SO4, and a neutral species. So if it's a neutral species, then you have to think about, okay, what is sulfuric acid? Is it an acid or a base? Well, it's an acid, okay, so which means that you need to form the conjugate base for it. To form the conjugate base, you need to remove one hydrogen from it. Okay, so that's minus one hydrogen, so it gives you HSO4 minus hydrogen sulfate ion. So that's the conjugate base. Now technically speaking, you can go one more forward because you still have one hydrogen left here, so you can form one more conjugate base here to give you sulfate ion. Now in an exam you may not have to do that, you maybe have to form just one, but sulfuric acid technically has two conjugate bases, the hydrogen sulfate and then the sulfate ion. If you were doing the reverse problem, if sulfate was given to you, then all you would have to do is add hydrogen to it. Okay, so if you add hydrogen ion, then you can get the sulfate to give you hydrogen sulfate. So between hydrogen sulfate and sulfate, okay, the hydrogen sulfate is the acid and sulfate is the conjugate base. So to go from conjugate base to an acid, you have to add hydrogen. So similarly here with the conjugate base for HSO4 minus the hydrogen sulfate ion, you can add hydrogen to this and get your acid back. Okay, so it's a whole cycle of removing hydrogens and then adding hydrogens, okay, to it, and that's how you end up dealing with the conjugate acids and bases. Okay, let's look at the next one, which is the amide ion, NH2 minus, and since this is already minus, it means it tells me that I have a base. Okay, usually, as I said before also, my negatives are going to be my bases. So which means I have to form a conjugate acid for this. To form a conjugate acid, you just add hydrogen ion, okay, and always H plus, not just H, okay, always H plus. So when you add the H plus, the plus is going to then nullify the negative over here. You add the plus and the minus, it becomes neutral, and so you end up getting ammonia, okay, for this. Now ammonia, as you know from before that we talked about, it's actually a base, okay. So this right now is the conjugate acid, which is really weird because this is actually a base, all right, but don't worry about that because you started with a base, so you should end up with a conjugate acid, okay. This one can go on further, by the way, and this is just a next step that I'm talking about, which is not the answer to this question. The answer to this question is this, and we're done with it, okay, but I'm taking you one step forward. Is if you were asked for NH3, that is, if this is ammonia and you need to form a conjugate base or conjugate acid for this, to form the conjugate base, you will take it back to NH2 minus by subtracting the H plus, okay. But to form the conjugate acid, you will have to add hydrogen plus to this, okay, and then you end up getting NH4 plus, which is the ammonium ion, okay. So this is again the conjugate acid, and you saw that over here also, okay, when I showed it to you here. So conjugate acid that you're forming for ammonia to give you ammonium ion. So anyhow, you can go back and forth all the time, all right. And again, if you remove H plus from here, you will end up getting the conjugate base, okay. So if NH4 plus was given to you and you were asked to write the base for it, you would just subtract the hydrogen and write the base, okay. So just a matter of adding, subtracting hydrogen. So here again with the fluoride ion, since it's the negative, you add H plus to this, and this becomes HF, all right, and so that's going to be your acid. So the first thing you should do is, of course, identify what you have, is whether you have conjugate acid or base, okay, and it doesn't have to be conjugate, you can just say this is base, and so then you can add H plus to that. Okay, then here we have the next one where you have CH3 Nh4 plus. And in this case, since this is a plus, I know that I have an acid, okay. Remember, positives are going to be acids and negatives are going to be your bases. So now what you have to do is subtract the hydrogen. It's really important for you to know which hydrogen to subtract because there are two hydrogens here, one connected to the nitrogen and one connected to carbon, okay. So don't bother with the carbon one over here, just remove the one from the nitrogen, okay, and eventually you're going to learn about why we do that. But otherwise, think of this NH4 plus as ammonia, so that's the part that's working. The CH3 is just for decoration for now. So then this gives you NH3, and this is going to be your conjugate base then, okay. All right, let's look at the next one, which is E over here, C6H5OH2 plus. Again, since I have the plus sign here, I know that I have acid. So then again, I have to remove a hydrogen in order to get my conjugate base, okay. That's where I'm going with this. Again, you have two hydrogens, the one connected to carbon, do not touch them, okay, just leave them alone. So remove the hydrogen from oxygen, so C6H5OH, okay, that's going to be your conjugate base then. The next here is F, which is C6H5O minus, and as soon as I see minus, I'm like, okay, I got a base here, okay. So once I have a base, I know I have to add an H plus ion to this. So oxygen has the minus here. Again, don't bother with the carbon, okay, just leave that alone. So C6H5 and then OH, and this becomes my acid, okay. And if you want to be more thorough, conjugate acid. So that's how you would figure out acids and bases and write conjugate acids and bases plus and minus of hydrogen ions.